Let's talk on to electronic displacement. Through these only you can understand the resonance and even all those electronic effects, resonance and even inductive effect, electromeric effects and even a hyperconjugation effect. So in order to know the electronic displacement effects, so you need to know about the electronic displacement first, where I will take the general atoms A, B, C, which are bonded. There is a A to E, there is a double bond, and B to C, there is a single bond. If the bond pair between A and B shifts on atom, then A to B single bond remains, and B to C single bond remains. These two electrons which are there in this single covalent bond, here one electron is of B, one electron is of A. If both the electrons shift on, I already told you that the double headed arrow will represent the two electron displacement. So these two electrons, if they come on B, this is the electron of P, where there is no change in the sign, and this is the electron of A, so that one electron is extra and one electron charge is -1. We can write minus also, so minus and -1 same, so that represents one electron. Here I have written two electrons, here you have written two electron, and you are talking about -1. I already told you one electron is already that of B. So if both the electrons will come on this, one electron from A is only the extra. So the charge is of that electron only, and the one electron is lost by the A, so that it will get the positive charge. Here one more electronic displacement is also there, A to B. In some cases, let us suppose lone pair is already there on some atom. It will go like this. So what happens is, the lone pair is converted now as a pi bonded pair of electrons. So A, B, C. Here two electrons are there. One is retained by B and one more goes to C. So here C gains one electron, becomes minus, and B has lost one electron to C. That is what it will get, the positive charge. So these kind of electronic displacements are there. One more, like in a functional group, I will take the example C double bond O, OH. If you see this carbonyl group is a divalent carbon containing carbon-oxygen double bond. In these two atoms, oxygen is electronegative. How one can decide electronegativity? This is based on the periodic table, where the species from these kind of things. So here there are two groups are there, here 6 groups are there, middle 10, and F block elements are here. The elements coming on right hand, like if I stand in front, the right hand elements, the RHS side elements are electronegative. So as I move from this side to this side, electronegativity increases. So you need to look like that. Here 14th group carbon and 16th group oxygen. So oxygen is more electronegative compared to carbon. This is the way how we decide the electronegativity of the elements. So more electronegative element means it has a tendency to attract a bonded pair, or it has a tendency to attract the electrons. So bonded pair, if they are attracted towards that atom, what happens is, I am showing the general formula like R, here C, single bond remains and O will get a negative charge. Single bond remains and the one electron is from oxygen, another electron is from carbon. If both the electrons are shifted to oxygen, one electron is already of oxygen, it shifts from this side to this side, let us suppose. One more electron will come like this and that will gain a negative charge. And here the oxygen and hydrogen. Since one electron is lost to the oxygen, this carbon will get the positive charge. In this way, the pi bond and the sigma bonds, they displace the electrons. In order to know the basic nature, acidic nature and stability of organic compounds, we need to know about their electronic effects, the electronic effects involved in those compounds. Without understanding the electronic displacements or the electronic effects, we can't understand the acidity, basicity, and even the stability of the organic compounds. And by understanding all those electronic effects, we will compare all those set of organic compounds, how they are acidic, how the acidic nature is more compared to another compound. So such comparison we can do. Let us talk on to the electronic displacements, where the first is inductive effect. Here I will give the information about which effect is permanent effect, which of them is non-permanent, temporary. Here the electromagnetic effect is only the temporary effect, and remaining all of them are permanent effects. Let us talk on to the first one, which is inductive effect. Inductive effect. Here there is a bond between the carbon present in this methyl group and the chlorine. There are sigma bonds between carbon chlorine, carbon hydrogen, carbon hydrogen and carbon hydrogen. In these, let us talk on to the bond between carbon and chlorine, where chlorine is more electronegative compared to that of carbon. What happens is, the more electronegative element tend to attract the bonded pair of electron. So it tries to increase the electron density on chlorine, so that chlorine will get partial negative charge. Sir, students will ask like that. Sir, there is a bond and chlorine is attracting the bonded pair of electron. Why don't completely negative charge? Why don't you write complete charge? You are writing only the partial charge. Here, bond will not break. If the bond breaks, then I will write the complete charge. But here, bond is not at broken. But the electron density is shifted towards the nucleus of chlorine, because chlorine nature is more electronegative. So more electronegative of nature of chlorine will triggers that chlorine atom to draw the bonded pair of electron, which is a sigma bond. So sigma bonded pair of electron are displaced towards the more electronegative element, and that will take the partial negative charge and this will take the partial positive charge. So this effect is known as inductive effect. So inductive effect is the electron displacement effect, where the sigma bonded electrons are displaced towards more electronegative element by taking the partial negative charge, and that atom which leaves those bonded pair of electron towards a more electronegative element, that will take the partial positive charge. So this is called as the inductive effect. The atom or group of atom that has the electron attracting inductive effect, so that will be the, for chlorine, if I consider for chlorine it is minus I effect, because it has electron attracting inductive effect. If I consider the methyl, it is donating its electron towards the chlorine. So it is electron repelling in nature. So if I consider this group, electrons, bonded pair of electrons are going away from this group substituent. So here with respect to methyl group it is plus I effect. So that I can call it as electron repelling inductive effect. So remember the point, inductive effect is a permanent effect of electron displacement in which sigma bonded electrons are displaced towards the more electron negative element by gaining partial negative charge, and that atom which leaves the electron will get a partial positive charge. Now moving onwards with the examples related to inductive effect, where the let us suppose R Mg X is there. This is called as Grignard's reagent, where this is not polar compared to this one. This is polar. This bond is polar, where the carbon containing, this is the alkyl or aryl group where the carbon is present, and this is the electropositive element. So that this is electropositive means the displacement of electron towards the alkyl or aryl group takes place. So that this will take a partial negative charge and this will take partial positive charge. After the attack of a reagent, this bond will break. But before getting broken, the sigma bonded electrons are shifted to that R, that is alkyl or aryl. So with respect to this group where there is a negative charge and it has attracted the sigma bonded electron, so this becomes minus I effect with respect to, I am telling, with respect to alkyl group. With respect to this group, it has repelled, it has given away the electron towards the more electronegative atom, that is carbon, which is present in this alkyl group. So with respect to this, it is a positive I effect. So that kind of electronic effects are there. We will discuss these things further in the examples in detail. Okay. So now coming to the resonance effect or mesomeric effect. Here this is also the permanent effect. The resonance effect is also the permanent effect, where let us suppose, I will take one example, CH2 double bond, let us suppose CH single bond, CH double bond, CH single bond, C double bond, OH. Writing one more example, let us suppose CH2 double bond, CH double bond, CH single bond, NH2. Okay. Here I have written two species, two organic compounds in which the resonance effect or mesomeric effect takes place. So a resonance effect is a permanent effect whereby polarity is produced. Here all those effects will talk about the polarity, and this effect is, in addition to polarity, it will discuss about the stability. So if I talk about all those electronic displacement, they will talk about the stability and the electronic displacements. Okay, so electronic displacement will produce a polarity. So polarity and stability, they will give the information about them. So permanent effect, where the polarity is produced inside the molecule due to interaction of pi electrons, pi electron and pi electron, or pi bond or pi bond and lone pair. So the permanent effect, the resonance or mesomeric effect, is a permanent effect of producing the polarity inside the molecule, where there is an interaction between two pi bonds or one pi bond lone pair. So two types are there between two pi bonds interaction or one pi bond and lone pair. So it's a permanent effect whereby polarity is produced due to interaction of pi bond or pi bond and lone pair. Here if I talk about this compound, what happens is there is a double bond between carbon and oxygen where one of the bond is pi bond, and we already know that the bonded pair of electron, the pi bonded pair of electron will shift towards the more electronegative atom. In this case, oxygen is a more electronegative atom. So bonded pairs are if they are shifted towards the oxygen. What happens is, I am writing the resonance structure of this. Resonance structure is nothing but I am displacing the electron according to their nature. Okay, and I am writing the resultant structure of that. That is the resonance structure. Here, how I decided? I have taken the pi bond between the carbon and oxygen. Here carbon to carbon are there, here to carbon and carbon are there. I have chosen a more polar bond, which is between carbon to oxygen. Carbon to carbon is less polar compared to carbon to oxygen pi bond. Okay, so that is the basic thing you need to know about that particular point. So the more polar is carbon to oxygen bond. Here what happens is there are two electrons are there in that bond. One is of oxygen and that is of carbon. If both the electrons are shifted to oxygen, what happens? The carbon is having the single bond with the OH and double bond with the oxygen. Here, one electron is of oxygen, remains with that only. There is no change, charge. Here, one electron is of carbon. That is also shifted towards the oxygen and that will get the -1 charge. So due to having one extra electron, and that carbon will get the positive charge, let us suppose. So here what happens is the remaining things I will write. CH is there and a double bond, and here CH single bond, here also CH double bond and CH2 is there. What happens is, in order to balance this valency, what happens? This pi bond, now this pi bond is shifted as a lone pair. Now this bond pair, in order to balance the valence of this carbon, it shifts on this side where there is a double bond comes. Here what happens is this electron is of this carbon and that remain on carbon only. Okay, this is like this one. CH is there. So initially it is like this. Okay, I have shifted only this bond where it gets a negative charge, carbon has a positive charge in turn. If this electron come on this side, let us suppose carbon, here this is the electron of this carbon, this is the electron of this carbon. This carbon is retained by this carbon. This electron is retained by this carbon. And the electron of this carbon is shifted here, where the carbon gets one electron and it becomes a neutral. So there is a pi bond between the first carbon and the second carbon. The electron from the third carbon is shifted to the carbon which is at the first position, so that the electron deficiency arises on third carbon. Again, in order to balance the valency, what happens is there is a conjugation, double bond, single bond, double bond. This is, we call it as a conjugation. So there is a pi bond between the fourth carbon in this structure. This is the first carbon, second carbon, third carbon, fourth carbon and fifth carbon. So between fourth carbon and fifth carbon there is a one more pi bond. This electron is shifted to this side. So it remains on fourth carbon only. So the electron on fourth carbon will remain on fourth carbon only. But the electron of the fifth carbon will shift to the third carbon, which is already electron deficient. If +1 of the third carbon, one electron from the fifth carbon comes on that, so +1, that electron from the fifth carbon is -1, so cancels. This becomes a neutral again, as it has occurred in between the first carbon and second carbon, the third carbon and fourth carbon, that remains same. So here finally the electron which is displaced from fifth carbon will get positive charge, because the electron of fifth carbon is shifted to the electron deficient third carbon, and that electron deficiency becomes a neutral, and finally this electron has lost the electron and fifth carbon becomes the electron deficient carbon finally. Now there is a polarity is produced inside the molecule due to interaction of pi electrons and lone pair. So interaction, pi electron is converted into lone pair. I will tell one more example. Here, if I take this as a substituent in my view, I am considering this as a substituent because the electronic displacement has started from this point only. If I consider this as a substituent, the substituent has gotten the negative charge where the electronic displacement takes place towards itself, so that it becomes a minus M effect. So the electron attracting resonance effect. So if the electronic displacement takes place towards the electron withdrawing group, so that electron withdrawing resonance effect is called as minus M effect. And here this is a substituent where the electron rich center is there, which is a nitrogen, donates lone pair, and lone pairs are converted into bond pair. Now I am going to write the resonance structure. Resonance structure is nothing but the structure, resultant structure after the displacement of electrons. Here we will write the same structure: CH, CH, double bond, CH, single bond, NH2. Okay. I will not start the electronic displacement between carbon and carbon. I will not start that point. I am starting from this point only because this is more polar. As I have explained, you need to start the electronic displacement from the more polar atom. So what happens is, here the more electronegative element containing lone pair is donated to this bond. So what happens is, one electron is of nitrogen, so both the electron is of nitrogen. One electron will remain on nitrogen only, but one electron is accessed for this carbon now. So nitrogen has lost its one electron to first carbon. Here no carbons are there. Here there was a carbon on that substituent only. Here there is no carbon. So this is the first carbon, second carbon, third carbon, and fourth carbon. Here the two electrons were there as a lone pair, and one electron is displaced, is retained on nitrogen only, and one electron is given for carbon. Now carbon has a positive charge and nitrogen has a, since nitrogen has given the electron, nitrogen has a positive charge, and the carbon has gained one electron extra from that nitrogen. Two electrons were there, two electrons were there. This electron came here, this electron came here. One electron retained on nitrogen, one electron is only given to carbon. So by taking one electron, carbon becomes a negative, and giving one electron to nitrogen becomes a positive. Again, in order to balance the valency, since this electron is there on this carbon, again what happens is, if these electrons come here, these electrons will go like this. So what happens is, again in order to balance the valency, so what happens, the lone pair are converted into bond pair, plus bond pair is shifted to again a bond pair, and here bond pair is shifted as a lone pair. This electronic displacement has gone away from the substituent. So this is called as, with respect to this group I am talking about. So electronic displacement is away from this substituent, so that this is called as plus M effect. Positive mesomeric effect is the resonance effect, where the electronic displacement of the pi bonded or a lone pair shifts away from the substituent. So this explains about the positive mesomeric effect, and this explains about the negative mesomeric effect. Now moving onwards with the electromeric effect. Now the electromeric effect. What happens is, this is also the electronic effect, but it's a temporary effect. Here also polarity is produced, whereby polarity produced due to displacement of pi bonded electrons towards one, we can't take towards, on we'll take pi bonded electrons on one or the other atom. Under the influence of attacking reagent. Try to focus. It is a temporary electronic effect. It will remain until unless there is a remnants of only attacking reagent. So under the influence of attacking reagent only this effect takes place. As soon as the attacking reagent is taken out from the reaction mixture, the reaction stops. This effect will stop right out there only. Okay. So it's a temporary effect, whereby polarity is produced due to displacement of pi bonded electrons towards one or the other atom. Here one species is there which contains a pi bond between carbon and carbon. Now here I am taking the attacking reagent as a electrophile. Now I am attacking the electrophile now. Since there are two types of attacking reagent having the positive and negative charge. Positive charge electron deficient, not only positive charge, electron deficient center is called as electrophile, and one more guy is attacking, and we will take the electron rich center, which is called as nucleophile. Here the attacking reagent is a electrophile, and here attacking reagent is a nucleophile. If the electrophile attacks this carbon, in order to attack this carbon should have electron rich density, so that the pi bond which is present between this carbon and this carbon will shift to this carbon only. So what happens? This is the electron of this carbon, will remain on that carbon only. Okay, will remain on that carbon only. This is the electron of this carbon. If comes, one electron becomes extra, so that this will get a negative charge and this will get a positive charge. So this one electron is extra coming from this carbon. Now this is the polarity produced, where initially it was like this. Both the bonded electrons come over here. What happens is the hydrogen, carbon, hydrogen, double bond was there, hydrogen and hydrogen, electrophile attack with this carbon, and the electrophile is electron deficient center. This should be electron rich in order to attack, so that in order to be the electron rich, this gains the electron density, where one electron of this and one electron from this carbon, negative charge, only one negative charge. Two electrons displaced, but one electron is already of this carbon, one electron is from this carbon, it will get the positive charge. And now electrophile will attack here, positive, and here negative. Two electrons were there. That the electron was here and it has retained on that. Now it is displacing on that only. So that carbon retains that electron. The one electron which came from this carbon is donated towards the electrophile and positive charge by gaining the electron of this. will be neutralized so that the bond formed between the electrophile. So this kind of reaction is there. Now, this I have called as a attacking a reagent. Here, under the influence of attacking reagent, the displacement of pi bonded electron takes place, and that too towards the attacking reagent. Here, the attacking reagent was attacking, and towards the towards that electrophile that electronic displacement takes place. This we call towards. The electronic displacement takes place towards, so that the positive charge is gained. So this is called as plus E effect. That the electronic displacement takes place towards the electrophile or attacking reagent. Here what happens is that in order to attack this position, this carbon should be electron deficient, because this is the electron rich center. This should be the electron deficient center. In order to be the electron deficient center, this carbon should lose the pi bonded electron, so that the electron displacement takes place like this. So what happens is, the hydrogen carbon, and this is a hydrogen double bond was there, and hydrogen nucleophile is electron rich center, and it is going to attack this carbon, and the electron displacement will take place away from this carbon, so it should be positive. By gaining the electron rich center, this becomes the electron negative. So there is a bond between nucleophile and the carbon takes place. So if the attacking reagent on this side, the electronic displacement taken place away from it, so that this effect is called as minus E effect. Next is hyperconjugation effect. This is also the permanent electronic effect, where the sigma bonded electron of alkyl group is displaced from or displaced to the carbon attached to unsaturated system, means which contains at least one double bond or one pi bond. Okay, so carbon attached to unsaturated system or p orbital or unshared p orbital containing atom. Here it's a permanent effect whereby the electrons, that sigma bonded electrons are of a alkyl group, are displaced to the carbon attached to unsaturated system, or the carbon which is pointed to that carbon which contains unshared p orbitals. I will tell you both of the cases here. Here this is a methyl group. So methyl group binded to that carbon containing multiple bond. So unsaturated system. So alkyl group binded to unsaturated system. Here the alkyl group binded to that carbon having unshared p. Only 3 orbitals are there. So sp2, one more p has a deficiency. So 1p is deficient here. So this is the case now. Okay. So what happens? Let us suppose here also, let us put one more alkyl group. Here also one more alkyl group. Okay. So this carbon has 3 bonds, sp2, and 1p is deficient. Now, so unshared p orbital containing atom. Unshared p orbital is there, and this is the carbon which contains unshared p orbital. Now, this is the sigma bond. This is the electron of this carbon that comes here, and this is the electron of that hydrogen which comes here. And now, this bond is shifted on this carbon. So what happens is, if I take the whole molecule, like a CH double bond CH2, this we call it as a unsaturated system, where this is called as allylic carbon. Allylic carbon is nothing but the sp3 hybridized carbon binding to sp2. Okay, so our unsaturated carbon directly binding to sp3 is called as allylic carbon. So this allylic carbon loses the bond, or it displaces the electrons between this carbon and hydrogen here. So carbon retains its electron, the hydrogen electron comes here, and this pi bond shifts on this carbon, which gets a negative charge, and this gets a positive charge, like this one I will show. Here sigma bonded electrons are shifted here, and this pi bond was there, and this is shifted on here. So what happens is H, C, here H, single bond CH, double bond CH2, where this becomes a negative, and this sigma bond is shifted between the carbon and hydrogen and break down, and this gets a positive charge. So now allyl is having the stability. Allyl carbanion is now getting the stability. So in order to explain the stability, this effect is there. Now coming to this point, where there is electron deficiency on this, and carbon's electron remain on carbon only, and the hydrogen will give to this carbon. So electron deficiency goes because it has taken away this electron, and now hydrogen becomes electron deficient. So this is one hyperconjugation structure. So initially it was like this, where there is an electron deficiency on this carbon. So I am showing the alkyl group sigma bonded displacement towards the unsaturated system and unshared p orbitals, where these electrons come like this, and hydrogen C H, here H plus, and a double bond C, here CH3, and here also CH3, like this. For a tertiary carbocation, butyl carbon, 1, 2, 3, 4 carbons are there in this carbocation. So this is a tertiary butyl carbocation, where there are 9 hydrogens are there. So on dissociating all these 9 hydrogens, we are going to get the structure like this. Like if I take this hydrogen, these pi bonded electron come like this. If I take this particular thing, what happens is EH plus remains, and this carbon hydrogen, and this carbon hydrogen double bond C, here CH3, and here CH3. So that such structure will arise like 9 in number, because the hydrogen, sigma bonded hydrogen are 9 in number. Due to these all 9 hyperconjugation structure, tertiary carbocation is most stable among those all carbocations. Tertiary is more stable. Tertiary, due to having more number of hyperconjugation effects, then secondary carbocation, then primary. It will come like this. This also the same if it is a free radical, tertiary carbon free radical. What happens is, here single electron will move. So here one electron from carbon remains on carbon only, one electron displacement, single-headed arrow. So carbon. Here one electron from that hydrogen will come here. Here already one electron is there, 2 electrons are there, 2 electrons are there. One electron will come here, this electron will come here, this electron will come here. So one electron. This electron, the electron from this carbon will come here. So one electron is displacing on hydrogen. Like that, there will be the 9 structure like that. So that So the hyperconjugation will also explain about the stability of free radicals and even the carbocations.